Welcome back, boys and girls, to iTTV's lesson of Form 1 Mathematics. We are now moving into the new chapter, and ever readily this chapter is known as Lines and Angles. Are you ready? Let's get started. Lines and angles. In this lesson, we will take a look at the characteristics of lines and angles, then move on to see types of angles and properties of angles. Later, we'll be taking a look at intersecting lines. And here, once again, we will see types of angles and the properties of angles applied. Next, perpendicular lines, and finally, parallel lines. At the end of this lesson, you will be able to understand the concept of angles, the concept of parallel lines, the concept of intersecting lines, and the concept of perpendicular lines. First, the concept of angles. Properties of angles. An angle comes from the Latin word angulus, meaning corner. An angle is a measure of turn or rotation. The larger the rotation, the larger is the angle formed. An angle is formed when two straight lines or arms meet at a point known as the vertex. Let's take a look at this diagram. You can see that when two arms meet, we call that as the vertex. And there you have the angle. Say suppose, students, when you turn around the corner, or if you turn the pages of a book. Now, as a result, you will see the amount of turn that is happening, and this will result in an angle. Denoting and labeling an angle. Boys and girls, there are three ways. The arms AB and BC meet at the vertex B. Therefore, an angle is formed at the vertex B. An arc is then drawn from AB to BC, and that represents the angle. As you can see in this diagram, we can represent the angle as angle ABC or angle CBA. Therefore, students, if you observe the diagram carefully, you can see that the angle is placed at B. Therefore, when we write, we will have to write it down as angle ABC or angle CBA. Note that the alphabet B is always in the middle. Alternatively, students, you can also opt to label the angle with a lowercase, such as in this case, the lowercase b. And thus you can call the angle now as B. As a tip, remember, when three uppercase alphabets are used, the alphabet representing the angle at the vertex must be written in the middle. Also, students, you have to remember, when a lowercase alphabet is written above the arc, this symbol is not used. To have a better understanding on these angles and the vertex involved, let's take a look on the board. Dear students, we are now trying to understand how to denote and label angles. So, let's take a look at this triangle. Now, this triangle is known as triangle PQR. And if I'm going to denote or label this angle at the vertex Q, how would we do it? This is how we're going to do. We can first opt to do this. If you're using three uppercase alphabets, then make sure that the vertex which is involved for the angle is always written in the middle. So the alphabet that's representing the vertex will be written in the middle. And on both the other sides, we will have the other vertices. Therefore, PQR. Now, how do we know that this is referring an angle? Therefore, you will use a symbol. This symbol refers to this angle, which is known as angle PQR. Let's take a look one more time. Angle PQR. You can see that when we say it out, two arms are meeting at vertex Q. That alphabet is always written in the middle. Alternatively, boys and girls, you can also label or denote this angle by labeling x over here. Now the moment we have labeled x, see that it is in the lower case, right? Now we can simply tell that x is this angle. Are you clear? Now boys and girls, you can understand that we already have two methods of writing them. Now let's take a look at this again. Angle PQR denotes this angle, right? What if I see it from this side now? Angle RQP. Does it also denote the same angle? Yes. Therefore, it is not wrong if you write it this way. Angle, always place the Q in the middle because this is the vertex in question now. RQP. Students, there is one more way in which you can represent the angle that we are discussing. By just writing an uppercase Q like this. But remember, if you're using the uppercase to represent the angle, always use this symbol of angle. Therefore, these are all the different ways in which you can write out to represent a certain angle. You can understand this for sure, right? Just to make you feel really comfortable with the idea, let's do a few more examples. But this time, I want you to try it out first. Go ahead and write out for angle at vertex P. How would we write it out? You should know by now. Let's try it and see. First, since this is the vertex and this is the angle that we are interested in, let's write the alphabet P first. Make sure it's in the middle, okay? Two other vertices are Q and R. Thus, QR are written by the side of P. Always do not forget to add the symbol. So how would we say out this angle? Angle QPR, right? We can also see it from this side. If it is from this side, then you will say what? Angle RPQ. RPQ. Or we can label a lowercase alphabet here. This example, I have picked Y. You can just write Y. Or you can opt to write the uppercase, which represents the vertex over here. But every time when you use an uppercase, remember to add the symbol of angle. It was easy now, isn't it? Let's try one more time and see if you can ace it. Now very quickly, tell all the ways in which we can denote the angle found at vertex R. Go ahead. Ready? Now let's check our answer. Angle PRQ. Angle PRQ. Alternatively, angle QRP. Or label in the diagram a lowercase alphabet of your choice. I've picked Z over here. Done. Or there is one more way. Just write out the uppercase alphabet found at the vertex and add the symbol angle. It is easy, isn't it? So, one done. Let's move on with the next part in lines and angles. Measuring an angle. The units of angles are degrees with this symbol or radians represented by the abbreviation RAD. As a tip, remember boys and girls, radians is not taught at this point. A protractor is used to measure an angle. A protractor is labeled with two scales. The inner scale measures angles from 0 degrees to 180 degrees in an anti-clockwise direction. The outer scale, however, measures angles from 0 degrees to 180 degrees, but in a clockwise direction. Boys and girls, take a look at this protractor. Now I'm sure every one of you have a protractor with you, right? Now go ahead, take a look at your protractor as well. Every protractor comes with two scales. One is the inner scale and the other the outer scale. Now let's take a look at the outer scale here. It goes from 0 degrees all the way to 180 degrees. But this is now going clockwise. What about the inner circle? It is also going from 0 degrees to 180 degrees, but this time it's moving at an anti-clockwise direction. There is another important line here. This line. Boys and girls, this line is known as the baseline. Check your protractor out, it also will have a baseline. Here, boys and girls, you have the center of the protractor, and this center will always have to be placed on top of the vertex in which you're trying to calculate the angle. So when you place the center of the protractor on the vertex, on any vertex, make sure that the baseline is aligned to the arm or one of the arms. This, boys and girls, is your introduction to the protractor. Let's carry on. Steps to measure a given angle with a protractor. First, place the center of the protractor on the vertex or the angle that is to be measured. Next, make sure that one of the arms is in line with the baseline of the protractor. Then, start from the 0 degree where the arm passes through. And finally, read from the scale where the other arm crosses. Students, take a look at the board now. I'm going to show you how to use a protractor. Now pay attention to these arms that are drawn over here. Now, this, boys and girls, is the vertex. So let me call this vertex as vertex A. Okay? I'm going to now teach you how to use a protractor to measure this angle. You ready? Let's take a look. First, place the center of the protractor at the vertex. Now the vertex should be clearly visible to you. Next, step 2, always align your baseline with any one of the arms. This is the arm that we're going to align it with. So move a little bit so that it aligns. See, boys and girls, it's placed right on the vertex. Baseline is aligned to the arm. Now, since we're going to read the angle from here, you can see that the inner scale is at 0. So let's read the inner scale all the way up to here. Now, this, boys and girls, will be 50. Therefore, remove your protractor. You already know that this angle is 50 degrees. Let's try another example. Take a look at these two arms. This is the vertex. I'm labeling it as vertex B. Draw up an arc to show the angle at vertex B. Our task is to measure this angle. Once again, step by step, do it along with me, alright, boys and girls? Place the protractor. Thus that the center of the protractor is aligned to the vertex. Baseline of the protractor aligned to one of the arm. Here we'll use the inner scale once again because it starts from 0 over here. Let's see, where does this line come to? it's here. If it is here, boys and girls, this is 129. Therefore, the angle is 129 degrees. Alternatively, boys and girls, you can also do this. Place the center of the protractor, but this time I'm going to align the baseline to this arm. So let's turn it. Okay, you see it's aligned over here now, but this time I'm going to use the outer scale from 0 all the way here. Once again it meets here. This is 129 degrees. You see, it doesn't matter which arm you pick, because at the end you will always get the same angle if you use the protractor correctly. Now let's take a look at this other example. We have two arms. This is the vertex. Let's label the vertex as C. This time the angle that I want you to find would be this. It's much larger angle now. Okay, you ready? Let's do it together. Center of the protractor goes to the vertex. Let's align the baseline to one of the arm. It's well aligned. Which are you going to use? The inner scale or the outer scale? Yes, the inner scale. Why? Because it starts from 0 over here all the way to 180. Boys and girls, we have a problem here. What's the problem? You see, the protractor can only be used to calculate 180, is it? This is where you need a skill. The arm here is going beyond 180 degrees. Therefore, follow the steps carefully. Read until 180. Put a mark over here. Then, lift off the protractor. Place the center again at the vertex. But this time, align the baseline to this arm. And it's aligned. Now read using the outer scale, 0 right up to here. This would be 49 degrees. Thus, boys and girls, the entire angle would be 180 until here, plus with 49 degrees is the balance, thus giving you the total of 229 degrees. Easy? Good. Make sure you practice few more times on your own using your own protractor. Let's move on. Draw an angle of given size. Follow the steps below. First, draw a horizontal line and mark a point on it. Next, place the center of the protractor on the marked point in step 1. Make sure the horizontal line lines up with the baseline of the protractor. Then, read the scale from 0 degree until the required size of the given angle and mark a point at that position. Finally, join the first marked point with the second. As a tip, remember always to make sure to have enough room above the line. Dear students, since you already have learned the methods in which to draw an angle, let's put our knowledge to the test here. This would also serve as an example for those of you who didn't actually grasp it yet. So say suppose I want to draw an angle of 52 degree. How much? 52 degree. First step, very easy. First step, we'll draw a horizontal line first. Done. Then on this line, place a mark. Now, once you have this mark over here, take the center of the protractor, place it on the mark make sure the baseline aligns or lines up with the horizontal line that we have just drawn. Okay, does it line up now? Very good. Now boys and girls, can you repeat back? What angle did we want to draw? 52 degrees, right? Always start with the 0. Since here the outer scale, 50, 1, 2. This is 52. Let's put a marking at 52. Remove the protractor. You can opt to use your ruler after this. Join both these marks. Pull it up. Voila. Boys and girls, you have already drawn an angle. This is 52 degrees. This is the vertex. These are the arms. It's kind of easy, isn't it? Now, since we are learning all about angles, there are many different types of angles that you need to know. Let's take a look. Types of angles. The types of angles are named according to their sizes. Take a look at this table. We can see the types of angles are acute angle first. The size of the acute angle will be between 0 degrees and 90 degrees. Thus the angle will be greater than 0 degrees but lesser than 90 degrees. This diagram shows an example of an acute angle. Next, a right angle is precisely 90 degrees. Thus, the angle will look like this. Next, let's take a look at an obtuse angle. An obtuse angle is greater than 90 degrees but lesser than 180 degrees. Thus, this image represents an obtuse angle. Finally, we have a reflex angle. Reflex angles are angles which have greater than 180 degrees but lesser than 360 degrees. This diagram shows you an example of a reflex angle. As a tip, remember boys and girls, this symbol means the angle is 90 degrees. Since you have already seen the table just now, are you sure that you have already memorized it? Let's put you to the test. Let's take a look at the board over here. I've written out few angles. Now, I'm going to tell you what these angles are coming under which category, but before that, make your guesses. Ready? Let's take a look at the first. 75 degree. Now, 75 degree is more than 0 degrees but less than 90 degrees. If it is more than 0 and less than 90, it goes under which category? This is an acute angle. Very good if you guessed it right. If not, try again. We have got another one here, 158 degree. Now 158 degree is above 90 degrees but lesser than 180 degrees. If it is above 90 and lesser than 180 degrees, what is it? Obtuse angle. Did you get it? Let's try this one. 91 degrees. Oh, it's got to be a right angle, right? Wrong. If it is 90 degrees, 90 degrees, then only it is a right angle. Now this is above 90 but less than 180. Therefore, this too is an obtuse angle. What about 312 degrees? Now this is more than 180 degrees, but it is less than 360 degrees. Therefore, what is the name for this? Reflex angle. Very good. Let's check this out. 48 degree. More than 90 or less than 90? Very good. It is between 0 degrees and 90 degrees. Therefore, it is an acute angle. One more. 184 degree. This is more than 180 degrees, less than 360 degrees. Therefore, reflex angle. Very good. 200 degrees. More than 180, less than 360. You made the guess right. It is a reflex angle. So you've put yourself to the test and I'm sure you are happy with the results that you have guessed. Let's move on. Angles on a straight line. Angles at a point on a straight line add up to 180 degrees. As you can see in this diagram, a straight line always equates to 180 degrees. Therefore, in this next diagram, A plus B has got to be 180 degrees. What about this diagram? We have A plus B plus C on a straight line. Therefore, A plus B plus C is 180 degrees. As a tip, remember, two angles fit together on a straight line are called supplementary angles. So boys and girls, you have learned something new now. Supplementary angles. What are they? When we have a straight line and when two angles fit together, these two angles are known as supplementary angles. So let's take a look at this diagram. Here, A and B are supplementary angles. However, here, A, B and C are not considered as supplementary angles because supplementary angles refer to only two angles that fit together on a straight line. Let's take a look at this example. In the diagram, POQ is a straight line. Find the value of x. Now as you can see, since POQ is a straight line, the total angles should be 180 degrees. Thus, let's take a look at the solution now. 118 plus x plus 31 equals to 180. Now remember, this is because the sum of angles on a straight line is always 180. Thus, 149 plus x equals to 180. Therefore, x is 180 minus 149, which gives you x is 31 degrees. Take a look at this example on the board, students. Now, we have a straight line. We've got 1, 2, 3, 4 angles. A 48 degrees, A 56 degrees. Our aim is to find the value for A. Now very easy, watch carefully, I'll do it step by step for you. Now remember boys and girls, what we said earlier, the total sum of all the angles on a straight line has got to be 180 degrees, right? Therefore, A plus 48 degrees plus A plus 56 degree is equal to 180 degrees. Now, let's group the A together. A plus A will be 2A plus 48 degree plus 56 degree equals to 180 degrees. Now let's isolate 2A. 180 degrees minus 48 degrees minus 56 degrees. Students, if you solve this, you will be getting 76 degrees. Now, is this the answer? No, this is not the answer. Why? Read every question that you come across very carefully. In the diagram, we wanted you to find the value for A, not the value for 2A. So how are we going to find the value for A? Very easy. A equals to 76 degree divided by 2, thus giving you 38 degrees. Now boys and girls, the value for A is 38 degrees. Angles around a point. Angles about a point add up to 360 degrees. As you can see in this diagram, the angle around this point is 360 degrees. Therefore, boys and girls, remember, a complete circle will always equate to 360 degrees, such as in this diagram. A, B and C, in which A plus B plus C will be 360 degrees. For example, find the size of the unknown angle. Remember, a complete turn is 360 degrees. And this symbol means 90 degrees. Therefore, boys and girls, x plus 90 degrees plus 132 degrees plus 24 degrees is equal to 360 degrees. X plus 246 degrees is equal to 360 degrees. Thus, x equal to 360 degrees minus 246 degrees, which gives you 114 degree. Boys and girls, how is lines and angles thus far? It's not that difficult, but it's lots of fun, isn't it? And with this, boys and girls, we have come to the end of this lesson. But don't worry, there's a little bit more for you to learn and understand, which we'll bring to the next lesson. Thank you for watching ITTV. Stay tuned.